Hello guys, welcome to this new session on AWS Big Data session, Big Data training. So let's start with the Big Data, AWS Big Data, with the understanding of Redshift because Redshift is very important chapter or important part basically of your AWS Big Data. So Big Data means huge amount of data that that needs to be extracted, that needs to be ingested that needs to be ingested, that needs to be extracted, that needs to be loaded, that needs to be transformed also. So the lot of things are there when you talk about the big data thing. So when you talk about AWS big data, AWS data analytics part, so Redshift is a key. Redshift is a basically uh, it's a data warehouse from Amazon. It's a cloud multi-tiered data warehouse solution from Amazon. Now, Amazon Redshift uses SQL to analyze the structured and semi-structured data across the data warehouse. But it uses SQL, but it is not use SQL to transfer the data from and to data warehouse, the Redshift. So basically, Redshift is inspired by the PostgreSQL. Maybe you might have heard about PostgreSQL. So PostgreSQL, it's a database. It's a open source SQL database. So Redshift is somewhere, inspired by the uh, PostgreSQL. And from performance point of view, if you ask me, then Redshift is 3x performance, better performance when it comes to the other competitors. So data can be ingested by multiple ways, but uh, data insertion of data is not through our insert statement. So Redshift uses different terms to, different technology or you get different commands to basically to transfer the data and to transfer the data from different sources to the Redshift data warehouse thing. So let's start our journey. It's a small video. I'm not gonna talk more about other stuff of the AWS big data, but let's take Redshift and let's see what is Redshift, what are the main components of Redshift, the architecture of Redshifts, and the basic fundamentals of the Redshift. So Amazon Redshift is a fully managed petabyte scale data warehouse. Petabyte scale means the capacity of the AWS Redshift warehouse is huge, and it's a cloud-based, fully managed petabyte scale warehouse. That is the reason it is more flexible, more available, and um, more economical, basically, to keep your data in the AWS Redshift data warehouse. So that's a definition. Now, let's get into the more detail. So in SQL, I mean in a Redshift data warehouse, you can query the data with the use of SQL. And that's a good thing. That's a great thing, right? You can use the SQL commands to query the data from Redshift. But remember, you can just query the data. You cannot insert the data. You cannot, uh, you know, push the data through SQL. There is a separate command for that. So what kind of database? What kind of data we can insert in that? So it's RDBMS app. Different application can insert the data basically. RDBMS application um, can insert the data. Um, operates as a relational database management, but it is not a relational database. The point here is you can query the data, query the Redshift as a SQL query, but it is not a SQL database, right? Based on the PostgreSQL 8.0.2, but contains a number of difference from the Postgres. It's inspired by the PostgreSQL. So data can be pushed from various different sources. That sources can be CSV, that sources can be S3 bucket, That sources can be any existing application. That sources can be streaming also. So there are different sources from where you can get the data. Once you get the data, once you get the data in S3, in Redshift, the first thing that you do is data cleansing. Data cleansing means making sure that there is no duplicate, there is no, um, you know, the data consistency. Basically, you are checking the consistency of the data. So that is called all data cleansing. That the steps are called data cleansing. That will be performed by the Redshift. Now the second part is extraction, transform, and load. So let's try to understand what you mean by extract. ETL term is normally very common, but if you're totally new to this AWS Redshift or AWS Big Data, then let me explain you that extract, what do you mean by extract? And then we'll learn transform and then we'll learn load. So let's see what do you mean by extract. So extraction means different sources, like it's for example, online, mortar system, legacy system, Salesforce system. So all these sources, these are the data sources from where you are taking the data and keeping it in the staging platform, the staging part. What do you mean by staging now? But why we are keeping the staging? So staging means intermediate thing, means it is not, data is not yet reached to the final destination. That is called the staging part. And then the transformation part is something you are changing the, you know, you are applying some rules or you're applying some transformation. For example, the Spark transformation is there. That Spark transformation, the Spark transformation will do it will, try to find aggregates like how out of 100 people, how many people got a US visa. So that kind of thing, the aggregation and the selection criteria, those things, that process is called transformation. You transform the data, and then once you are done with the transformation, then you can load the data. So that is called loading. So loading a data uh, to data warehouse to Redshift data store, Redshift data warehouse. So Amazon Redshift cluster. When you talk about Amazon Redshift, it's a cluster. Now definitely cluster means definitely it's not only one server. And obviously this kind of a setup, this kind of a petabyte setup cannot be handled by a single server. So we have multiple servers in the cluster. But it is not a group of servers that will make a Redshift cluster. But the important part is the loader node, a leader node basically, and then there's a compute node, and there's a database. So the database, it's a location of your data, but the compute node is the one who will actually do the computing, and the leader node is the interface for your Redshift. And this is called the Redshift engine. This part is called Redshift engine. So the flow is something like this. The third party application will connect to the leader node. The leader node will send the queries to compute node, and compute node will do some parallel processing, massive parallel processing on the data which is stored here, and get the data, get the output, or get the transformation, or whatever the data you want to send. They send the data back to the leader node, and the leader node will send it back to the application. So this is the very high level thing. So leader node, you need to remember compute node and the database. So definitely for leader node, some specification should be there. Some compute node, definitely compute node means a lot of CPU power, memory power should be there. So we have a different type of compute node. The configuration, like for example, your uh, the CPU and the memory stuff that is required for you to execute uh, multiple executions in parallel. So these are the external apps, they are connected to leader node. So that is the first, your interface is a leader node. So these things normally ask the interview that, can me explain me the Redshift architecture. So Redshift architecture, the first thing that Redshift stands for is a massive parallel processing. So the compute node, if you see the compute node are, divided into the slices, and these slices hold the data. And the hold the data means hold uh, the processing to slices are there to process the data. If you have more slices, then you have more parallel processing can be done. So this is the typical example of the node type. Um, if you see this DC2 large, DC2 extra large, 8 large, DC1 large, DC1 8 large. So the CPU, number of CPU, number of RAM, default slice per node, storage per node, node ranges, and total capacity. So these are the node that will do your actual job for processing your query. For a developer understanding on how to select the best distribution style, there are distribution style in um, in the compute node. How we get the distributed, how the slices node slices get distributed. There's a there's a fundamental behind that. We will cover those things on our main training. But understand the concept behind the high level overview of compute node and leader node. So the leader node is your interface for your Redshift. All the application will connect to the leader node, and from leader node it will go to the compute node. And how we connect to the leader node? Through ODBC and JDBC, you can connect all your application, analytics, business, or BI, BI applications. All these applications, BIC, are connected with the ODBC and JDBC. So Amazon Redshift is extremely powerful when it comes to the analytics, the different tools which Amazon Redshift support that provides a 3x faster performance than the cloud data warehouses. And why it is faster, that also we will see. What are the secret recipe of Redshift? See, the secret recipe for the Redshift is the massively parallel processing. So compute node, if you see the compute node, so if you go for any simple SQL statement, that's called insert. That insert comes in the batch form, and when that comes in the batch form, it will get executed only in the one node. And if it is multiple batch process, then it will occupy only one or two nodes. But Redshift supports massively parallel processing (MPP), and that is the key recipe here. So even if you send a query to Redshift, multiple queries, then it will distribute those queries to the multiple compute node. That's the first trick. That's the first thing. That's why it is extremely fast. So the leader node, as I said earlier, the leader node has an execution plan. So leader node will execute the thing which are the plan, and then it will execute those things on multiple compute node parallelly. So that will increase the performance. Now what's next? What's next is a next thing is very common and very powerful thing, that is a columnar store. So it is based on the columnar. So data gets stored in the columnar, not in the rows. And that is the reason it is much faster to retrieve the data. Rather than writing the data, the performance always get counted how fast your query run. Right? Query means ultimately you are extracting the data, or kind of you are sending the query and trying to get the data out of that. So that columnar store will read the entire column. So it's if you see this number, if you uh, get the one column you need to read every time, it's very easy rather than 10 rows you need to read one by one by one. So when you read the row, it is a batch process, one by one by one by one by one by one. But when it comes columnar store, it's a parallel thing. That's why it is Again, there's a second recipe that is very fast. And result caching. So leader node will cache a lot of results, and if the results and the next time the query comes and the result is there in the cache, then it will send it to the cache rather than getting back to the compute node and asking them to, you know, do the query again. So that is the basic, the recipe of your Redshift success. So CPU utilization, throughput, and query load performance, these are the main features of Redshift. Now, Amazon Redshift cluster, how do we access this cluster? Who can access? That is something can be performed by IAM role. IAM role is there. When IAM role is there, then the leader node can connect to the S3 bucket also, or the data lake also. So IAM role plays very important role. There are one more option is there, that is called your secured key and secret key and access key. We will look into that now. Now coming back to the Redshift, our Redshift command that will be using to insert the data into the Redshift cluster. So there is no insert command. So the command that we use to insert the data is the copy command. So if you see there's this Redshift cluster, I mean Redshift warehouse, the columnar database with the shared nothing architecture that does massively parallel processing. That's a key. This is more columnar store than your row-based thing. That's main thing. That is why it is much faster than any other data warehouse solution. The Redshift should not be treated like a relational database. Always remember, you can run the query, but it is not treated as a the SQL database. It's a large-scale data analytics and not for individual transactions. So it is designed for a large-scale data analytics platform and not for your small database with the SQL database. Again, I said insert will not work here. The only thing that will work here is the copy command. And the copy mean how we can insert the data from the copy command. It's something like this. So copy will read the manifest file or simple copy command. The syntax of that copy command is something like this. Copy sales. Sales is a target. Here, always remember the first thing is the target, and this is the source. And the second thing, a third thing is the role. So there are three things which are required to insert the data. One is the sales, one is the target, source, and IAM role. If you want to copy data from um, different S3 buckets, data, the majority of data that comes to the Redshift, Amazon Redshift is from the S3 bucket. If you want to push the data from different multiple S3 bucket, I would say, then you can use the manifest file. This copy command that we use. Basically, the the bottom line is that you need to use the copy command. Loading data in a sort key order reduces the need to vacuum also. Means whatever data you have, if you do the sorting, then it will be very easy to insert. I mean to copy the data basically. So before you copy the data, or before you insert the data, make sure that you do the sorting. And manifest file will tell the Redshift that these are the sources, these are the target, and these are the rules. Just copy the data from these S3 bucket. But imagine if this bucket is empty, then it will fail. So we need a mechanism that will tell the Redshift that if the bucket is empty, then we will not copy the data. So if you are trying to avoid a resume building event using manifest file, ensure that only the required data is loaded and all of it accounted for. So manifest file makes sure that if there is no data, then it will not execute any command through copy command. So basically, this is the target, this is the source, this is the IAM role, and this is the manifest. When you say manifest, so it will look into this S3 bucket for this particular file. If file is not there, then it will not execute any copy command. So if you're trying to avoid resume building event, means you're copying the data. By the way, when you copy the data from to Redshift cluster, it will not append. It will just append. It will not modify existing data. It will just, at the end, it will start appending it. This is a typical your manifest file. So I have different sources. These are the different sources from these are the URL, and mandatory means yes, you need to look into that file. These are the typical features of that. Source data can be in multiple format from multiple data source. It will manage data transformation. It can control access to the loading data. It manages the load operation also. So remember guys, one thing, that copy command is the main command for the Redshift. We'll do the lab also in our next session. We will do the, I'll show you how we, do the copy command, copy, in Redshift. But this is just a fundamental training about that. So this is the source and this is the target. When you copy the data to target, it will append. It will not insert in particular row. It will go, in the last line, and it will start appending it. So the problem here is, if you have a source data, I mean the target data has some source data, then there is a chance for the duplication also. So how to manage that duplication, we will see that. But see, these are the different sources from where you can get the data to your Redshift. One is your EMR cluster, one is your DynamoDB, one is your EC2 instance, and one is the SSH keys. So SS for S3 bucket, the from condition would be something like this. If it is EMR cluster, then this is something like this. We'll cover the EMR cluster in our big data training in classes, so don't worry about that. SSH means if the source system is a Linux system and you are sending the data from Linux system, so you need to have a manifest file. In that manifest file, you need to mention the IP address of that system, so that it will connect to that system and start sending the data. So as I said earlier, there are two options are there. One is IAM role or access key and secret key. Access key and secret key is not a secured way to manage it, because we need to share those access key and secret key, and that is the reason Amazon is and AWS is basically recommending the IAM rules. So here, if you see compute date, max errors, no load, so these are the features of your copy commands. The different things that you are doing that from the copy command. So use no load to check validity of data file without actually loading the data. Something like your Terraform. You might have heard about Terraform check, right? So that is something like that. So these are the checking features. These are the features of your copy command. Now, as I said earlier, there can be chances that data get duplicated also. So how to manage the duplicate data? It's a upserding. The upserd command is there. Through that you can manage. So that's it for today. We'll connect tomorrow again and we'll talk more about that.